How does the internet work? As a developer, it's important to have a solid understanding of what the internet. Yeah, in this article we'll cover. Okay, introduction to internet. Before we learn internet, and yeah, we know what internet is. Group of computers connected, and yeah, doesn't matter how the internet works. How the internet works. This things at a high level. The internet works by connecting devices and computer systems together by using sets of standardized protocols. These protocols define how information is exchanged between devices and ensure the data is transmitted reliably, reliably and securely. The core of the internet is a global network of interconnected routers which are responsible for directing traffic between different devices and systems. When you send data over the internet, it's broken up into smaller packets that are sent from your device to a router. The router examines the packets and forwards it to the next router in the path towards its destination. This process continues until the packet reaches its final destination. Yeah. So a packet goes from your device to the routers, and then routers route them basically, and basically then it reaches the final destination. To ensure that packets are sent and received correctly, the internet uses variety of protocols, including internet protocols (IP) and the TCP. For IP is responsible for routing packets to their correct destination. TCP ensures the packet are transmitted reliably and in correct order. In addition to these core protocols, there are a wide range of other technologies and protocols that are enable communication, DNS, HTTP, and secure socket layer SSL. Like you need an SSL certificate for HTTPS. As a developer, it's important to have solid understanding on different topics. And I think these topics are taught in, like, obviously we are taught in computer science courses, but like sometimes I also blame myself because I wasn't that focused. Like COVID was the reason, but uh, and I fought like freelancing gigs and money came to me, so I thought, why should I learn all these topics? And now I feel that okay, I actually needed these topics. But then I also feel like not everything was taught. Not everything was much more focused on like uh, learning, like remembering stuff than actually understanding. Okay, this happens and this happens and then this happens. There was no uh, way of connecting everything. Everything was just told to you. Okay, this is this, this is this, this is this, and now you, if you can connect it, you connect it. If you can't, then okay, that's so fine. That's not what it's is in the exam. That is basically what the education system is. So you can't be very like everyone got the same spoons, let's say. So you can't be very complaining about that. But yeah, that is what it is. What it is. Packet, a small unit of data that is transmitted over the internet router, a device that directs packet of data between different IP address, unique identifier assigned to each device on a network. You use the route data for correct destination. Domain name, a human readable name, DNS, human is responsible for translating domain names into IP address. So you write google.com and then DNS transfers it to the basically it's it's kind of a hash map. So you write google.com, it sees okay it's google.com, so it just changes it to the IP address that is in the namespace google.com. Key, for the key in google.com. HTTP is used to transfer data between clients such as web browser and servers such as website. HTTPS encrypted through to provide secure communication between clients. SSL, TLS, a secure sockets layer, transport layer, security protocols are used to provide secure communication over the internet. Yeah, so basically this thing is what how college teaches you. It teaches you, okay, remember all these, and that's the benefit of it. That okay, now I remember like what these are. But it never teaches, like it does not teach you well enough how these things are connected, and that you learn by yourself. uh, Role of protocols on the internet. Protocol play a critical role in enabling communication and data exchange over the internet. The protocol is a set of rules and standards defined. Yeah, there are different protocols used for internet communication. So why do we need a protocol? We need a big in a world without protocols. Um, let's say computer A and computer B want to talk, but computer A does not know how the like let's say uh, a person from rural India and a person from the US want to talk. So the person in rural India says speaks his own language, and the person in the US mostly speaks English. So now they don't have a communication channel between them because they have no way to talk to each other. So the protocol is basically the language of that talking. So now, if there's a translator between them, the translator is a protocol basically. If they both speak in the same language, then the language is the protocol basically. So that's why you need protocol, and why what a protocol is. There are many different protocols used in internet communication, including internet protocol. Yeah, TCP, transmission control protocol. That was TLS, no? TLS, transport layer security, and this is TCP, transmission control protocol. UDP, user datagram protocol. So I think TCP creates a message circuit, and then the same path is followed by every packet, and but UDP um, has that like every packet is sent. If it reaches, it reaches. If it does not, then it does not. So, like every packet uses the best possible path that it can find, but on TCP, one path is chosen and to be the best possible path, and then I don't remember like exactly all the differences. I remember the basics of it. IP is responsible for routing correct destination by TCP and UDP. Ensure packets are transmitted reliably and efficiently. DNS is used to translate uh, domain names into IP address, and HTTP is used to transfer data between client and server. One of the key benefits of using standardized protocols is they allow devices and systems from different manufacturers and vendors to communicate with each other seamlessly. For example, a web browser developed by one company can communicate with a web browser developed by another company as long as they both adhere to the HTTP protocol. As a developer, it's important to understand the various protocols used. Yeah, it's universal, uh, and you must know them. IP addresses and domain names IP are both concepts to understand. Yeah, IP address a unique identifier ensuring that information is sent to independent intended recipient. IP addresses are typically represented series of four separated periods such as this. Now that's IPv4. Now there's also IPv6 now. So, which is completely different from IPv4. It's not a version thing. It's not backwards. IPv6 is not backwards compatible. So IPv4 does not work with IPv6. So now devices have both IPv4 and IPv6. I think some devices don't have IPv4 now. Like they did start uh, only using IPv6, but yeah. Domain names, on the other hand, are human readable names used to identify websites and internet resources and typically composed. Yeah. And DNS is basically does the mapping of domain names to the IP. Introduction to HTTP and HTTPS. HTTP, Internet-based application and service. Uh, HTTP protocol is used to client and server when server asking for a package or, or the resources are requested. The server then sends the HTTP response back to the client containing the request data. So REST APIs are basically HTTP requests. Uh, or uh, like when you make type in google.com in your browser, then it makes a HTTP request to get google.com from the server. HTTPS is more secure, encrypts the data being transmitted using SSL and TLS, so secure sockets layer and transport layers. Security encryption, this provides additional layer of international payment information and other personal data. When you visit the website that uses HTTPS, your browser will display a padlock. Yeah, so something like Arc does not have that. I think does Arc have? Yeah, I guess this. Yeah, this is the SSL certificate. I guess by CS.fyi. Building application with TCP/IP. TCP, underlying communication protocol used for most internet-based application and service. It provides reliable order error check delivery of data between applications running in different devices. When building application with TCP/IP, there are few key concepts to understand. Ports. Ports are used to identify the application or service running on the device. Each application or service is assigned a unique port number, allowing data to be sent to a correct destination. Yeah, so let's say I'm running the Arc browser right now, so the Arc browser will be on some port. So that's how the communication can happen. Like if you there has Google Chrome, so Google Chrome will have some port exposed, so it will be on some port. So all the programs that you have that run continuously are on support. Uh, like that require network, I think. I may be slightly wrong here. Like I have some doubts. Like all the programs or the programs that require network are on port. I think the ones that require network have a port. I hope so. Let's uh right now let's believe that. Let's check now. Program have a port. Software will only have one or more port numbers so a program with a network connection. I was right. Um, a socket is combination of IP address and port number representing a specific endpoint of communication. Sockets are used to establish connection between devices and transfer data between applications. I was always confused what they call as a socket, but now I understand. It's basically like IP address plus port. Uh, connection is established between two sockets when two devices want to communicate with each other during the communication establishment process, the device negotiated various parameters such as maximum segment size and window size, which determine how data will be transmitted over the communication. Okay. Data transfer. Once a data connection is established, data can be transferred between application running on each device. Data is typically transmitted in segments with each segment containing a sequence number and other metadata to ensure reliable delivery. Okay, good. Everyone understands the word data transfer. It's nothing uh, to be explained about. But each data has a sequence number and other metadata to ensure reliable delivery is the important point, I guess. And the important point for connection is maximum segment size and window size. I like so. What is a segment size? I remember learning about it, but I think I have forgotten exactly what it is. But yeah, mm, I don't remember actually what it was. Window and segment size is size of each packet. Window, I don't know. Uh, okay, yes. I remember. Okay. Yeah. So let's say that we decided on a segment size. Segment is basically a packet, and window is the number of packets that are in buffer. To let's say the receiver has a window size of let's say 10. I don't know if this is the exact mechanism, but this will clear you what is a window. So let's say so we know what is a segment. Segment is basically a packet, and segment size is a packet size. Now we don't want on every packet to be received. We send um acknowledgement back because that will take a lot of time and will and it's not that unreliable that we need to do that. It is only a somewhat unreliable that packets get lost. So now you on the receiver side there is a window that is like of let's say five. So you get five packets and after that those five packets if all those five are correct you send back an acknowledgement. That is what I think of sending drone versus oil tanker across Atlantic Ocean. If one thinks that its all contents are wasted, consumer you want loss may have to be small or equal. Yet small. Exactly. If you are on 10. And if the window fails, you transmit the entire window. So that is a drawback, but generally you pick a window size up according to the packet loss, and then uh, that prevents a lot of windows to be lost. How does the internet work? Okay, we were not here, we were somewhere. So, securing internet communication with SSL and TLS. As discussed earlier, SSL/TLS is a protocol used to encrypt data being transmitted over the internet. It's commonly used to provide secure connection for applications such as web browser, email clients, and file transfer programs. When using SSL/TLS to secure internet communication, there are a few key concepts to understand. Certificates. So SSL/TLS certificates are used to establish trust between clients and servers. They contain information on identity of the server and is signed by a trusted third party, a certificate authority to verify authenticity. So I showed you this. This is the SSL certificate and it expires on 10 December 2023. This is these are the details: common name, country of origin, organization. This is the encrypting organization. Let's encrypt. Uh, sign- uh, Signature algorithm. So how it is hashed. A lot of data. Uh, Encryption. When building, okay, handshake during SSL, TLS, handshake process, the client and server exchange information to negotiate encryption algorithms and other parameters for secure connection. Encryption. One, the secure connection is established, data is encrypted using agreed upon algorithm and can be transmitted securely between client and server. Yeah, no problem understanding that when building internet-based communication and service, it's important to understand how SSL and TLS works and to ensure that your application is designed to use SSL and TLS when transmitting sensitive data such as login credentials, payment information, and other personal data. You'll also need to ensure that you obtain and maintain valid SSL TLS certificates for your server, that you follow best practices and configuration for securing your SSL/TLS connections. By doing so, you can help protect the user's data and ensure the integrity and confidentiality of application communication over the internet. Yeah, so use HTTPS basically. Okay. The I think this one article only took 1 hour. We'll complete this and then we'll move on. Uh, we'll follow on in another live because I also have some other work to do. But yeah, uh, future emerging trends and technologies. Internet is constantly evolving. As a developer, it's important. Yeah, and 5G. So 5G is the technology that is very much in the what are my opinions on 5G? So I don't see 5G very hyped as 4G was. Like in especially in India, like 4G brought up a very big revolution. 5G is there. Uh, it makes things faster. To load a normal site, you don't need 5G. Just to download stuff very fast, you need 5G. Like if you are playing streamed games, I guess 5G would be a good thing. But not for normal things. 4G is good enough to get most of your like 90% of things could be done with 4G, and those 10 high download like things could use 5G also. And then new use case and applications such as autonomous vehicle and remote search. Yeah, those 10% of things. Uh, I prefer my doctor to not be remote. I prefer my doctor to be here in itself. So Uh, that's an hot take. I would not want my doctor to be remote. If in very extreme service cases when there can't be any doctor that does the surgery and is here, that only case I would allow that. IoT refers to a network of physical application devices, vehicles, home appliances, and other objects are connected to the internet can exchange data. As IoT continues to grow, it's expected to revolutionize industries such as healthcare, transportation, and manufacturing. Is IoT are self-driving cars IoT? I think they are. AI AI technologies such as machine learning and NLP are already used to power a wide range of applications and service. From voice assistant to fraud detection, and AI continues to advance it is experienced to enable new use case and transform industries such as healthcare, fintech, and education. Healthcare, transportation, manufacturing. Yeah. These are the fields that tech that people want tech to be at. Blockchain is a distributed ledger technology that ensures secure decentralized transaction. It is used for being power a wide range of applications from cryptocurrency. I don't understand the use case for blockchains. Honestly, like if like most of the things that blockchain does can be done like by normal systems and much more efficiently than blockchain. So I honestly am not that bullish on blockchain technologies. Uh, like obviously uh, it's not because right now the block like cryptocurrencies have fallen. So now a lot of people that were bullish are not. But I've never been so bullish on blockchain from the start only. Like I knew about blockchain when I was in 8th standard. I tried to mine some Bitcoin that time in a wallet. I think I might have mined some. I don't know. I don't remember, but I don't have that wallet now. So, but that point I was bullish uh, because I did not understand it fully. But the more I understand it, and it was a technology that, like, 8th standard means 8 years ago, so 8 to 9 years ago. So, but now the more I understand blockchain technologies, I just find it very inefficient compared to normal tech, and that's why I'm not very keen on blockchain. Computing refers to processing and storage of data at edge of the network rather than centralized data center. It is expected to enable new use case and applications such as real-time analytics and low latency application. Staying up to date emerging trends to ensure that your application service. And that's what we are doing. We're trying to stay up to date with past knowledge, and then that's then only you can